Bro, I know. 1%. I have a 92. All right, let's check these worksheets. You guys some points for them. And as we're doing that, I put the answers on the back. Did that help? Yeah. Or did you just use it to cheat? Awesome. I will go over questions if you have them about the chain rule worksheet in just a little bit. But as I'm checking it, I want you guys to start working out. This is the velocity time graph. Okay. So I want you guys to start doing this. You can do it in your notebooks. This is like I don't know, I wouldn't say it's a quiz review, but it's kind of like a quiz review. So we'll review some problems today. Just ready for the quiz tomorrow.
It's somewhere over there.
The key is on the back.
Oh no. Well, I don't have
Here come the excuses. Here come the excuses.
You said you made copies of them. I haven't taken
Yeah, it is. But you gotta.
I'll let it slide today. I like it so much more. Alright.
1.x. Product squared plus 1 plus 30. Product squared plus plus 30.
Where were you, Burkett?
Yeah.
Are they alright?
What?
Are they alright?
Yeah.
Maybe they
Should I scroll down or are we still working? Oh, you're probably graphing, right? Sketching it as well. No, it has not.
You're asking the wrong
Yes. Yeah, it's just one color. Not sure.
I think that is still
Trying to go for the third goal.
And my work's on the back. That's bad. I'm making that shooting at all. I guess you probably guys.
All right. Gavin, when is Parker moving to the right?
It's moving to the right between 0 and 1 seconds and 6 to 8 seconds.
How'd you write that? Inequality notation or bracket parenthesis notation?
Bracket parentheses.
So you wrote moving right. You put 0, 1 to 1. Did you put a bracket or parenthesis on 1? I agree. Union. And then you put 6 to 8. If you wrote it 0 less than 1 less than, 0 less than x less than 1, that's fine. And then 6 less than 8. I can talk, I promise. 6 less than x less than 8, that's fine too. All right, to the left now. Avery, what do you think about left?
I put from 6 to 8 and then 8.
Well, 6 to 8 it was moving to the right. How about the left?
Oh, I just wrote the wrong things. 1 to 6,
1 to 6.
and then 8 to 9.
And I'm going to take the blame for this. On the quiz, I'm going to try to make it obvious, like here. That, let's call that 9. If you put 8 to infinity, I mean, there's no arrow on that graph, so technically we wouldn't say 8 to infinity. I was a little lazy, and I guess I forgot to put the 9 there, or whatever unit that would have been. So I will accept your 8 to 9. I would be careful, though. If there's not arrows, you can't assume it goes on forever. In the book and on the quiz, I'm going to try to put on the interval from 0 to 9. On the interval from 0 to 9. When does the particle move? Right, left, stopped. Kylie, when did you put stopped?
At 1 and at 6.
1 second. Here, stopped at 1. What's your reason for that? Stopped at 1 because?
It's a velocity versus time, and it's a 0.
Perfect. So t equals, what was your next one?
6.
6 seconds. Any more?
Oh, and 8.
8. All right. Jaden, what'd you get for change direction?
At the same spot that it's supposed to stop.
Good. What if the graph would have done this? What if it would have gone down and then up? Change direction at 1? No. Moving to the right? Stopped and then kept moving to the right. Let me ask you this. Careful. If I said 1 is the particle moving to the right and you put 0 to 3. Is that correct? 0 to 3. No, because at 1, it wasn't moving to the right, it was stopped. Correct? Cool. When does the particle reach its maximum speed? When does it reach its maximum speed, Tom?
3 to 5.
3 to 5. And what is that speed?
10.
10, yep,
feet per second.
feet per second. Questions on that one? When is the particle's acceleration negative? Well, you're looking at velocity. You should be able to sketch the acceleration graph. Now, in general, like you'd have to know this value, right? Isn't the acceleration the slopes of this graph? So what's acceleration going to look like? It's going to be, is it going to be increasing, decreasing, linear? No, it's going to be constants, right? Acceleration is going to be constants. Here, the acceleration is going to be between 3 and 5. The acceleration is going to be 0. Very good. All right, well, let's answer the question. When is the particle's acceleration negative? Lizzie, do you think you are confident with that one?
Is it 0 to 3 and then 7 to 8 or 9?
Very good, yeah. 0 to 3, from 0 to, on the interval from 0 to 3, negative slopes all the way through. Negative slope, negative acceleration, because the slope of velocity is acceleration. 0 slope here, positive slope here, negative slope from 7 all the way to 9. Be careful, some people want to stop at 8, but the slope of that segment is negative all the way from 7 to 9. So 0 to 3, 7 to 9. All right, and again, I know if you took physics, you've done a bunch of these, but for those who haven't, are you okay with these now? Okay, is it getting better? All right, can you prove one of the 4 trig derivatives? By one of the 4, I mean not sine, not cosine, the other 4. You should be able to prove all 4 of those. Why don't you practice this one right now? This is just a good old practice day.
Oh, yeah.
We need a good old practice every once in a while. Practice day in math is like the quiet reading time in English, isn't it? Yeah, you don't like the quiet reading time? What if they were carpet squares? Would you feel better about it?
Yes.
If it was a carpeted room, what's the purpose of a carpet square? Whoops. Ownership, isolation, comfort. Yeah, looking back. How'd you do on that one? Tyler, you look perplexed.
Because I have no idea what's happening.
That's why. All right, this is what I called a trig proof, a trig derivative proof. You should know the derivative of cosecant x is negative cosecant x cotangent x. I'm asking you to show that it is. So we break it up into its identity, 1/4 sine of x. I use the quotient rule. I simplify it. I should get that. Does that make any sense?
Yeah.
I would practice all 4 of those tonight because it's going to be one of the 4.
You get calculated.
Calculator?
Yeah.
No calculator. All calculus. No calculator. Questions on that? Some fun things pop up with each one. Be prepared. I would say write this answer as 1 fraction. All right, to avoid frustration and anger, what is the overarching derivative rule you should recognize first? Product. Do you agree? Product rule. But within the product rule, first times derivative of the second plus the second times derivative of the first, within the product rule, you're going to have a chain rule. Good so far? Avery? Tom?
Why do you have the 5x minus 1 to negative 1/2 twice?
I only have it once. I have the negative 1/2 once.
No, like the second part.
The product rule is first times the derivative of the second. So the derivative of this thing is right here. But then the product rule is plus the second, as it is, plus the second times the derivative of the first. So my hint was to write it as one fraction. Did I get that? How are you laughing?
Do you have to like think about that before you do it, or do you just like start writing?
No, I've been teaching it for 15 years. Help me out. Where are you guys getting stuff? Luke? The algebra? Okay, so everybody freeze. Are we okay with the red and blue stuff? That's the product rule with the chain rule, yes? Okay. Then we took care of the negative exponents by bringing it down. Well, I gave you the hint of you have to have it as one fraction. We've talked about that. You want it as one fraction because I could look at this derivative and say that has a slope. The original has a slope of 0 when the derivative equals 0, right? At 6/45, right? I would add 6 divided by 4. 6/45. This graph has a horizontal tangent. That's nice to know in the next chapter. I could look at the denominator and say at 1/5, this derivative is going to fail to exist. It's going to cause division by 0. That's nice to know. All right. I wish I had time to graph it. We could do some beautiful analysis on it. However, we don't. So this is the key. Can you get here? Well, then, yeah. I mean, you are expected to be able to do this complex algebra. I made common denominators, so I multiplied times 2 times 5x minus 1 to the 1/2. I have to do it in the numerator. Well, look. 2 times 3, this is all commutative. 2 times 3 is 6. 5x minus 1 to the 1/2 times another 5x minus 1 to the 1/2. That's like a square root times a square root, isn't it? What's a square root times a square root? Whatever is inside, right? 5x minus 1. So I have 6 times 5x minus 1. That's 30x minus 6. 30 and 15 make 45 minus 6. Common denominators, we add them. We get one fraction. So, my caution to you. Step 1. Recognize the product rule. Do you guys all recognize the product rule? If you take the derivative of 3x and say 3, and you take the derivative of square root of 5x minus 1 and write that next to each other, you're going to miss a lot of points because you did not recognize the product rule. Right? Two terms being multiplied. Two functions of x being multiplied. So, another reason why I want you to be able to write it as one fraction. What if, on the AP test, this is a multiple choice question, and that's the answer they have? You know you have to get to that point, correct? You know you need to do that algebra to get to that point. Or if it's a multiple choice question on a quiz. Wink, wink. I need some sort of sound effect. In case a problem like this is on a quiz, multiple choice. Be prepared. Next one. Madison, did you get the hint there? Casey, you get it? Pick it up. I said too much. Get this one, Cole? How should well, help me out, just to avoid frustration amongst our peers. How should I rewrite this one?
I started with the exponent rule.
But how should I rewrite it?
I don't follow.
Cotangent square root 3x is the same as cotangent of 3x.
Square.
All right, you have some more time to work. Quick little checkpoint though. Is this a single chain rule or a multiple chain rule? Like Russian nesting dolls. Was it this class we had the joke?
Yes.
About the Russian nesting dolls? What was the joke? What was the one?
Oh, yeah.
Huh?
Something like that.
And they're always what? Inside.
Oh, yeah.
All of themselves, that was it. Yeah. Yes, this is a chain rule. But what's the outermost rule? Is it just a trig chain rule, or is it a power chain rule, or is it a quotient rule with the chain rule? Is it a product rule with the chain rule? That's what you have to start deciding. Which one is this? The power, right? The outermost is a power. If the outermost is a product, then you're using the product rule. All right. The derivative of the outer function was 2 blah to the first. We leave the inside alone. We're going to multiply times the derivative of the inside. But the derivative of the inside, it's not just cotangent of x, it's cotangent of 3x. It's another chain rule. Some of you might prefer to do the side work up to the, to the side and then insert it in right here. How many of you like to do that? That's fine with me. If you're a color coordinated person and you'd like to bracket off in different colors or write different parts in different colors, I'm fine with that. I'm flexible. All right, sometimes. All right, so what's the derivative of cotangent of 3x? Who wants to take that one on? Wendy.
Negative cosecant squared 3x times 3.
Do we give our approval? The derivative of the outer part, the derivative of cotangent, is negative cosecant squared. Blah. But it's a chain rule, so you recognize it's inside alone times the derivative that's inside. Right? So we have negative 3 cosecant. Thank you, Wendy. Cosecant squared 3x. So I would write it as negative 6 cotangent 3x times cosecant squared 3x. I like to write the coefficients, and x is out front. You know what it got me thinking? This was kind of an interesting one, right? Kind of weird looking. What if it was cosecant 3x? What's the derivative of cosecant 3x? Hmm. Lane, you got this? No? DeLuca, you got this? For some answers over there? What's your go-to bait?
I mostly use soft plastics and crankbaits.
Yeah.
I don't fish a lot with them.
Yeah, you don't want to touch the orange.
You know, I was putting some stuff away for the winter by our garden, and like, not a huge fan of snakes. And I've got a few snakes like around my workshop. Like, I've seen snake skins; they're getting bigger. I do not like snakes, so I got my son to get rid of them. But then I was uncovering. So they were like baby snakes. They were small, which are even worse. They were like really creepy. But then I was by the garden and I was like lifting something up, and there was like a pretty big worm, right? How many of you are scared of worms? 1, 2, just Cole. No. Why is it we're scared of snakes, but like not usually worms? Because like a big worm can be bigger than a small snake.
Worms don't have teeth.
Yeah, these ones not gonna bite though. You know, some snakes though.
You can
Worms don't
never
seem
be
like they're
sure.
alive.
You feel
Huh?
like a snake could come up and
Worms
touch
like
you.
don't have eyes or anything.
Worms
They're
are
not-
just there.
They're not gonna like attack you.
I love worms.
It's like spiders. I always think you're just gonna kill them.
Oh, yeah.
They're like a worm.
I have no problems with spiders.
They're not
All right, anybody overcome their fear of chain rules and tackle this one? Cole?
First step or the end?
Whatever you're feeling, Cole.
The first step, I found the derivative of cosecant, which is negative cosecant 3x
times cotangent 3x. And then I found the derivative of the inside, which is 3. Put all that together to get negative 3 cosecant 3x cotangent 3x.
Kind of a weird one, isn't it? So here's what I want to address right now. And if you're a flashcard person and you've made flashcards of the trig derivative rules, you may want to slightly revise them. We learned section 3.4, which was trig derivative rules. Derivative sine of x, cosine of x. Derivative cosine of x, negative sine of x. Then 3.5 was like velocity and other rates of change. Then 3.6 was the chain rule. So here's the deal. We learned the trig derivative rules before we learned the chain rule. So what if we want to remake our trig derivative rules, allowing for the chain rule? I'm not going to do all of these, but here's what I want to address. What's the issue here? The input is not just x, but you're taking the derivative with respect to x. Meaning u is what? Sorry, you are what? No, u is what? What is u? A function of x. Ooh, a function. A function inside of sine? Chain rule. Let's make the rule for this. Ready? What's the derivative of the outer function? Leave the inside alone. Times the derivative of the inside. What's the derivative of u with respect to x? U prime of x or d u dx. Thank you, Kyler. Du dx. Do you understand that? What's the derivative of cosine of u? Negative sine, leave the inside alone, times. So some of you are thinking at this point, that's kind of a waste of time. They're just all going to have a du dx tacked on the end. Yeah, until you get to a weird one like this, and you're like, what do I do with that? I know it's negative cosecant x cotangent x, but when there's a 3x in there, do I put the 3x in both parentheses? Yeah. It's negative cosecant u times cotangent u times du dx. There aren't two du dx's because it's the derivative of the originals inside. Just one of the threes. Just a 3 because of the derivative of the original ones inside. Does this make sense? So that's how you can generalize the chain rule for functions we've already taken the derivatives of. We learned the rules. We can go back and say, I bet we could use the chain rule on that and make our own rule. All right, next I just didn't feel like retyping. I apologize. We kind of did this one already in our homework and notes. I want to make sure everybody's good with this. Again, no calculator. The numbers are going to have to be pretty nice on the quiz for this kind of problem. Our position function is 160t minus 16t squared. How high does the rock go? Well, isn't this graph going to look like that? If I want to find how high it goes, that's a question of position. But I need to know the time when it is at its highest point. Use calculus. What's happening when it's at its highest point? The velocity is 0. So v of t is 160 minus 32t. Set it equal to 0. Add 32t, divide by 32. Again, this would have to be nice numbers. And for this one, it's 5. 5 what? seconds. Well, that doesn't answer that problem. The question asked, how high does the rock go? Well, at 5 seconds, the rock is at its highest position. So S of 5 times 160. Don't need a calculator for that. 800, right? Okay, people who struggle with mental math, watch. You're doing 5 times 160. What's 5 times 100? 500. What's 5 times 60? 300. 800. Minus, what's 5 squared? 25 times 16. Well, it's 25 times 10 and 25 times 6. 25 times 10 is 250. 25 times 6, what's 6 quarters? 50. So we have 250 and 150 is 400. We have minus 400. S of 5 is 400 feet. How high does the rock go? 400 feet. What is the displacement? Ooh, who can give me the definition of displacement? Final what? Final position minus initial position. So blank of 2 minus blank of 1. V or S or A? What is it? S of 2 minus S of 1. Position. S. S of T is position. And feet. S of 2. What's S of 2? 320 minus, 16 minus 16 times 2 squared minus 64. That's S of 2 minus S of 1 is 160 minus 16. Again, these will be nicer numbers on the quiz tomorrow. You guys can take that from there, correct? All right, what's the acceleration? Well, what's the acceleration function? And we'll plug in 2. If v of t is 160 minus 32t, then a of t is negative 32. What's the acceleration at 2? Feet per second squared. What's the acceleration at 5? It's always negative 32 feet per second squared. Feet per second per second. I don't know, but these types of questions tend to be the ones that students struggle with, okay? Practice these. They're in the book. There's practice problems. Average velocity. How do you, okay, how would you denote average velocity? Here's the 2 I get from 1 to 2. And I hate to put incorrect work up on the board, but it happens enough, I have to address it. Door 1, door 2, or door 3? Who votes door 1? 1, 2, 3, 4. 4 people. Who votes door 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who votes door 3? Goodbye, door 3. You're gone. Okay. I need everybody to stop daydreaming about what they're about to eat okay, or where you could be right now, other than calculus. I need you to focus on this. This happens all the time. Do you know how I hate memorizing things? So I typically will learn ways to kind of figure it out, right? I always let the units tell me if this setup is correct. What would S of 2 minus S of 1 give me in units? In this one, we have seconds, we have feet. S of 2 minus S of 1, F of 2 minus F of 1, F of B minus F of A would be in feet. 2 minus 1 would be in seconds. So this answer's units would be feet per second. Do you agree? V of 2 minus V of 1. Velocity at 2 minus velocity at 1. What's the units in the numerator for that one? Feet per second. Over. What's that? That's an average acceleration. You don't want that. Do you see how that's wrong? Yes? So guys, listen. Tomorrow on the quiz, average velocity, displacement over time. Displacement over time. Don't subtract velocity. All right? The last two problems were just practice with chain rules and recognizing a constant multiple rule versus a product rule. The number one thing we need to be careful of on the quiz as a whole is identifying the overarching derivative rule. All right? First, summative grade of the second 9 weeks.